To balance an assembly line, you must divide the tasks up among the workstations, and in order to do that, you have to know the cycle time. That's the very first piece of information, do you notice, that's being supplied at this point of this scenario? Let's look. Given that RDRS, that's Regional Disaster Relief Services, must complete one overnight kit every 90 seconds, that is another way to say cycle time. And we have found it. To have the kits ready in time for delivery, the 9 assembly tasks, these are what need to be divided. Picture below, here we go, must be divided among the volunteers who are going to work along one long table in the middle of the warehouse. RDRS will use longest processing time to balance the assembly line. Okay, this is known as the line balancing algorithm. We are going to take these 9 tasks and divide them up among the volunteers to create one smooth flowing line down that long table in the warehouse. You can remember line balancing if you can remember these column headers: station, time remaining, eligible tasks that will fit, and assigned. Because we design an assembly line by beginning at the first workstation. We decide what the first workstation, or in this case the first volunteer, will do, and then we go to the second workstation and the third and the fourth and so on. So to start designing this line, we begin at the first workstation. Now here at the first workstation, nothing's been done. That means time remaining, the entire budget of 90 seconds, also known as the right. You might want to note later, how did we get started? That is the cycle time. Is ready, remaining to be used. Okay, eligible tasks. Now here's where the diagram is helpful. Nothing's been assigned. Here at the beginning at the first workstation, we're looking for tasks that could possibly be assigned that don't have any immediate predecessors, right? Because they're things that somebody could pick up and do right now. You can find them on a diagram as symbols in which there may be arrows leaving the task, because the circles here represent tasks, but there are no arrows pointing at them. Tasks A and task B both fit that description. That means that they are 2 tasks at the beginning of the sequence, and either one of them could be assigned to station 1. Eligible tasks that will fit, this is a screening check. Okay, we have 90 seconds remaining. That's what it refers to as the will fit. We just want to check. A is 30 seconds long, that task. Sure, that'll fit in 90 seconds. And B is 60 seconds long. Sure, that'll fit in 90 seconds. And notice that it's a separate question in each case. We're not talking about their combined length or anything. Yeah, each one of them will fit. So just copy them both. They both basically pass the test. And then we decide who gets assigned. Here is where longest processing time, here is where the rule kicks in. LPT is a common abbreviation for longest processing time, and in this particular scenario it was specified that if you had a choice of what to assign, you would use that rule to make the assignment. So in the case of our problem here, we look for, okay, A or B, which is the longest? Well, B. B is 60 seconds long? Fine. B gets the assignment. B gets the assignment, and I can mark it off. B gets the assignment. Notice that it's 60 seconds long. That means here at the first workstation, there are now 30 seconds remaining. Now, how can I say that? Because we now know that the first workstation is doing, for a fact, task B. We know for a fact that takes 60 seconds. So 90, what we started with, minus 60, means, okay, here at the first workstation, there's still 30 seconds left to work with. Okay, then who's eligible? Well, A is still eligible for an assignment. B has already been assigned, but we can't go on to C because the 2 arrows pointing at C are telling us that both of these need to be completed before you can start on that. So we can't basically proceed down this line yet. Oh, okay, well that just means that A is the only thing now that's eligible. Okay. It's 30 seconds, it will fit. It will fit actually just perfectly in the time remaining. Oh, okay, and I don't need a rule because there's only one thing to pick from. I just made my second assignment. I made my second assignment. Okay, the first workstation will do task A and task B. Now that means that the 30 seconds that were left minus the 30 seconds that will take A, there are at this point no seconds remaining at that workstation. Well, now what are we supposed to do? Open a fresh workstation. We now know we've designed, if you will, workstation 1. We know what the first volunteer sitting at the table will do. We just draw a line under it and say, fine, open a fresh workstation. Meaning I have all 90 seconds to work with here when I'm making assignments. I have all 90 seconds to work with who is eligible. Well, A and B will have been done at the first workstation, and when they're both done, the diagram is indicating you can go on to do C, but that's it. Okay, so C is eligible. Quick check, 45 seconds fits into 90. C will fit. Again, don't really need the rule. That means C automatically gets the assignment. Great. Task C will be done at the second workstation. Now, task C is 45 seconds. 90 minus 45 means there's another 45 seconds still to work with here at the second workstation. Now that C is done, notice that a couple different options open up. You could, for instance, go on to complete task D, or task E, or task F. Any one of them, so I listed them here. They're all eligible. Now, eligible tasks that will fit. Remember, there's only 45 seconds left at this station. And I am looking up here at the diagram at task D, and it says it's 60 seconds long. Task D is not going to fit. I can't copy it over here. Task E and F, though, if you check their durations, each one of them would fit inside of 40 seconds. So that's all I have to pick from at this case, but I do get to pick, so I use longest processing time. Who is the longer of the two? Well, that would be F. F is 30 seconds? Fine. F gets the assignment. F is assigned, it's 30 seconds long. That means 45 minus 30, I now have 15 seconds remaining at that workstation. Now, who is eligible? Technically, D is still eligible in terms of precedence relationships. E is eligible. And now that F has been assigned and we know that F is completed, you could proceed on if you wanted to G. So we list it as eligible. Now we do the check for what will actually fit in the mere 15 seconds that are remaining. Well, D certainly wouldn't fit. Wouldn't fit last time. It won't fit now. E is 20 seconds long. You know, E is not going to fit either in the time remaining. Let's see, G. G is only 10 seconds long, so of the 3 eligible tasks, only one of them will fit in the time remaining, meaning I don't need the rule again. It just gets the assignment. G gets assigned to the second workstation. Great, now that means that there are 5 seconds remaining here at the workstation, and you can list again eligible D, E, and H is even becomes eligible now that G is done, but we only have 5 seconds remaining, right? So you can check each one of these, including H, which isn't too terribly long. It's not going to fit. There are no eligible tasks that will fit in the 5 seconds that are remaining. It's time for another workstation. That means that station 2 is done. Station 2 is done. Now that station 2 is done, we go on to open another workstation, station 3, a full 90 seconds, the same complement of eligible tasks. We're still trying to find home for these. Now we check who will fit, and since we have a fresh workstation, any one of them would fit, D, E, H. Oh, meaning now I need the rule to actually pick one of them. The rule is longest processing time, and D is clearly the longest one finally. D finds a home. Now, 90 minus 60 is 30. There are 30 seconds remaining. E and H are still eligible. I can mark D off my diagram, but we can't add anybody in terms of eligibility because the only other one on here is I, and all of these 3 would have to be done. No, too early for that. Still just working with E and H. Now, will E fit, 20 seconds will fit into 30 seconds, yes. H, 10 seconds will fit into 30 seconds, great. Okay, well then they both will fit. Longest processing time, which one of the two is longer? Well, that would be E. E gets the assignment. E gets the assignment, so E is done. See, 20 seconds means there's 10 seconds remaining. H is still eligible. I doesn't become eligible until D, E, and H are done, and the problem is H is not done. So H is all by itself. H is 10 seconds long, and actually that will fit just perfectly, so H gets the assignment automatically, and we are out of time at this workstation. And as I mark up here, I mark H off. We only have one other task that needs a home, and so I wind up adding a whole nother workstation onto the end of this assembly line just for that task, because everybody needs a home. The fourth workstation, 90 seconds remaining. At this point, who is eligible? I will fit. I was, what, 60 seconds? Right, and the whole reason I was adding that fourth workstation is so that I had a place to be assigned. The task I, not like me, I. Meaning there's 30 seconds left, but that's okay, because at the point that you have assigned each one of the tasks on the precedence diagram, you have completed the line balancing problem. You have designed an assembly line. Now, here's the interesting thing about line balancing. You've designed an assembly line just now. Sometimes it's not readily apparent. You go, huh, I filled out this worksheet. Where's this design? The design is right here. The whole reason you were filling out this worksheet was to get that design in the far right-hand column, because this is, whoops, first station. This is what the first station will do. This is what the second station will do, C, F, G. This is what the third station will do, tasks D, E, and H. And then, as we were remarking, the fourth station and the last station on this particular assembly line is there simply to complete task I.